Okay, cool. So yeah, this is the second video in which we will be going over the basics of Linux in general and how everything works. And yeah, I have a small project for you guys in the end. And yeah, that's about it. So yeah, let's go with it. So in Linux, first of all, everything is a file. Now you might say, what do you mean by everything is a file? Uh, by everything, I mean like everything. Like even the directories are a kind of file. So how can a folder be a file? Now it's not as a folder in general, it's a file that contains links to other files, or I should say other directories or files only. So it contains links to other files. That's how it is a file. So everything is like following a hierarchy here, which we will discuss more about it in the later videos. But it's I can just show you very quick. Linux hierarchy. So everything starts from here, the root, and here like this is the directory that from which the Linux boots into, then root, boot, bin. Not like boot has all the boot files, but yeah, we'll discuss this hierarchy as a whole in the next video. This is not about it, just a basic intro of it. And all of these files are like really important, especially the etc boot, which the boot looks into these files and everything. So here a process gets started in the, and this is the first process, and from here it has links to all these directories, and these directories have links to other directories and everything. So if we just very quickly open the terminal, so we will be using a lot of I would say everything doing in terminal only, rather than like doing it on GUI. I know like it sounds daunting at first, but trust me, just hold on. Terminal is the way to go. You'll just love it. So a very quick about the root thing. So I go into the root directory. Now I want to look what are the files that are in the root directory. So if you remember, these should be the files that are there in the root directory. How can I see those files? I mean, there should be a command, right? There should, yeah, there is a command called ls. Ls is list files. list list. So if I do ls here, you can see all of these files that are present here. Uh, these directories that are present here. Now if I do cd, now what is a cd? Cd is change directory. Now if I want to go into a directory, let's say into change directory home. Now going to the home directory. If I go into the home directory, I what is it? Let's do ls again. These are the two users that I have created. Like when you can create everything from the command line, like think of it like everything that you can do from GUI, that is graphical user interface, can be done by command line. Or is it, or I should say, first think of it like in the systems engineering, everything is on command line, because when you log into the server, you don't have a GUI. It's just a basic terminal that is given to you, and you have to do everything. And everything can be done, trust me. Yeah, so if I do again, like go into my own fold, like own directory, this is my own user that I'm logged into. Well, as again, these are all the directories that are present. So I am using a little bit of different thing that just helps me differentiate a little bit better. So if I see like the blue ones are directories, this one is a file. Now how can I view a file? for viewing the directories inside the directory, I show for viewing everything what is inside the directory, it's ls command. But now I want to view the contents that are present inside a file. Now, how can I view that? I do cat. Uh, but yeah, I can do cat. But before that, I would like to show you how do I create files. So so that we can view one file. I don't want to show anything else apart from that. That's right. So let's create a new file first. How do I create a new file? I create a new file by doing touch, and it's your new file .txt. And if I do this again, see, you see here a new file is there. Now what I want to do is I want to write something into the new file to view the contents of it. So how can I do that? Now there are various methods that you can write into a file. Most general way is use Vim. Vim is an awesome text editor. Like you can say hello. If I do insert hello, I can make a new. I can have a separate video on Vim. Vim is so vast and it's so good to use. Like it has a steep learning curve, but yeah, you'll get used to it. So, not going back to the topic. Hello, my name is Ralph. Now, if I want to save it, I just save it. Now, the file has the contents in it. How can I view that content? Of course, I can view new file like this here. But there is another way that is very commonly used, that is cat. So it just allows me to view the contents in the file and nothing else. If I want to make the change, I can do so. Double greater than signs. I'm not remembering the exact name of it. Appends to the file. So if I do new file txt, now if I write something, this is the second line. And if I do, it will, I think, be written into the first line only, because I didn't have a new space character and enter. I didn't press enter at the end. I think so, but it's really hard. Okay, I had a enter at the end, so this is now what? This appends to the file double greater than. If I do a single greater than, and I changed everything, and now I do a cat. Oof, where is all my content? So I use this single greater than sign. That means whatever is in the file, I want to remove it, and I want to write this new file. Rather than appending at the end, it just rewrites the whole file. So be aware of that. Cat is a very useful thing. You can always use Vim, but Vim is like a whole text editor in itself. And if you want to write code and anything, Vim is the way to go. But yeah, just viewing the files, yeah, I think Cat does a pretty good job there. There is Nano also. You can write here, exchange it. Nano is like in between. Might also have many more things, but this is the main use that I use Cat for. Nano also you can change files to it, but I mostly use Vim and Cat for that. But yeah, that's all about it. Now the next command. So remember we learned about how to make a new file. So new file txt. I made a new file again. Now what if I want to delete a file? Now a short way to delete a file would be to go here and just move trash. Now this is not the way. We do rm new file 2.txt because I deleted the new file, so we do not have new. It's the new file 2. Now let's look into ls again. Oof, we don't have the new file 2. It's deleted. Where it's gone? It's gone forever. I mean, you can find it in trash, I believe so. Let's just explore it. If you can find it in trash, new file, no. So the thing that I deleted with UI is available in the trash, but not with the command line. So it's a pretty destructive command, I would say, and use it with caution. Now, we created a file and I told you everything is a file list, but that doesn't mean that there is no folders. So folders are called directories here, which holds all the files and other directories in it. And how can we create a new folder then? So let's do mkdir. So make directory, because folders are directories here. So make directory. Now if I test directory and do ls here. So if you see, where is test directory? Here it is. I created a new directory. I want to go into that test directory. I'm inside the test directory. I create two new files, 1.txt, 2.txt, and 3.txt. And let's create two files. Sorry, I need to use Dutch. Sorry. 2.txt, 3.txt, and there is one more beautiful command if you want to do it. Tree. So all the files inside. So it presents you in a tree-like structure. It's a good way to look at it. Sometimes you want to look at it if you want to, but it does like this. So there are so many files here, and you'll get overwhelmed by it. So yeah, it's I generally don't use it like in short directories. You can use it beautifully, and yeah. So we have made the directories. Now I told you to delete the file, use rm. Now rm and 1, 2, 3, I can delete any of it. But let's go back a directory. Okay, so this is also an important concept here. To go, every directory has two directories in it. So every directory has two links in it. Now what are links? I'll explain it to you, but just hold on for a sec. So if I do ls -l, so it shows me list of all the files and also the hidden files here with a long list format. So -l. So if I do just ls it lists out all the files that are hidden. Now hidden files, you can think like some of the files are generally not shown directly, but if you ask for it, Linux shows it to you. So that's hidden files. Now I want to show it in a long list format, that is -l. That's what I did. So it shows you on the left, like if you look at it, on the left, if you look at it, it has these. Now what are these? These are permissions that are there for the particular file. So permissions, so the first character is the directory or a character file, like B, C, it generally goes like that, but it's a text file, so it doesn't matter to us. But after that, it's RWX, RWX, and RWX. RWX, what is that? R stands for read, W for write, X for executable. So we'll learn more about this in chmod command, that will come a little bit, but yeah, about that. But not about it. Here we see two different files. One is dot and one is double dot. What's that? So remember I told you everything is a file, and inside a file there are directories or files that are connected to that particular file. So this is what. So every directory that you see in Linux will have these two dots except root. So first dot is a link to itself. The second dot is a link to its parent. So if I do, and these are double dots, so these are directories in itself. So if I do cd, like I want to change the directory to double dot because it's inside this. I do a double dot and I go up. I am where? Like I executed that directory and I'm in the home directory. Okay. And now this is the first thing. Now if I want to like let's go again in the directory, and if I want to do ls, let's make a new directory. Now there might be hundreds of directories that are there. There might be programs that are there, and if you want to like do cd, like it will find inside test because that's only directory. But there is another way to find, that is dot and slash, and then you can type in the file name whatever it is. So inside test, the new directory, like this thing does it for me. Like this is a zsh shell, which like automatically does it for me. But yeah, in the if there is no autocomplete, I think you have to mention dot and slash, and then that's the path that we are talking about. So what is the path? A path in Linux is just the way that where is the directory stored. It's the location of that directory. And how do we get that? We can get it by let's go. So here you are seeing like the path of the directory, but if you want to get the exact path, we do pwd, that is print working directory, and we do. So I go in the home, in the my username test directory, inside test, that's the working directory. And it's a pretty useful command when you are like going over the code and want to make change, like want to see where you exactly are. Or in the servers generally we don't use these kind of fancy shells, so there we need like what is the working directory of it. Sometimes it's so, sometimes not. So there's a command for it. Sorry, and yeah, it does it here. Now I was talking about shells. What is a shell? A shell, you can think of something as a command interpreter. A command interpreter. Ooh, what's that? A command interpreter is nothing but just a way that how commands will be read by the system, by the kernel. So if I write pwd, it already has something that is like some program called pwd that is running with this command. It interprets that, okay, so user has written pwd, now I want to do this command. Okay, yeah, that's all about shells. Are like of many types. Bash, that is like generally installed on the systems in general. Then zsh, C shell, I think fish also is there. There are many kinds of it. I use zsh. It's like it's customizable and good for my work, for what work I do. So yeah, that's all about it. Now, let me look. There were some other things that I wanted to discuss. Directory, switch directory. Okay. Oh yeah, we talked about links. We talked about links. That this is a good thing. So, links. What are links? Links, in a very general way. Remember, I told you a directory has two links, one to itself and one to its parent directory. So parent directory has a link to the child directory, and child directory has a link to its parent directory because they want to be connected. And that's how. Now there are two types of links. One is the hard link and one is the soft link. Now hard link, what it is. Hard link is nothing but think of it like, suppose I create uh, how can I say, a new file is created that is the exact, like that acts like an exact that acts exactly like the file. So if I make a change to the original file, it you can see the change in the new file also. Sorry, in the file that has a hard link also. If I delete that file, this file also gets deleted, and like that. Now where we would need this, we generally need this to, like, we can think of it like a replication kind of thing. So there is no copy that is made of the new file, but we have the file. We make any change to it, we can see that change somewhere else. So a data, like, kind of a replication thing, not replication, but replication is like you have a new copy but you don't have a new copy, but it's available to someone else. So I can give you an example right now, but it will become more clear as the time progresses in this class. So we have a user group. We have one group which has the original file, and one other group needs to see what's inside the file, but we don't want to allow the access to the whole group. So we create a link of the file, give it to the user, like, so he can view just the file. Now if I make the change to this file, the original file, the user will see those changes made to the made to that file and can view that file. So that's one way that you can think of like a hard link. What is a symbolic link? Symbolic links, we all are aware of it very well. Everyone, I think, in his or her lifetime would have used the Windows or a Mac OS. So a shortcut, you can think of it like shortcut. Like a shortcut used to create shortcuts. Like, I think if I can show you here. So a shortcut would be a shortcut to settings. This is seen in GUI as a shortcut, but think of it uh, a path to the original file, a reference to the original file. That's it. That's all about it. If the original file is deleted, this file is also deleted. This file will not be deleted, but it it won't show anything because there is no reference to which it is pointing now. So where we would need this, we generally need this, like, suppose we have a container application and we want to view the contents in that file inside a container, because container has no access to the outside world of the whole machine. So we create a symbolic link to that file there, and we can just view that file as it's. But if the original file in the main server is deleted, we won't be able to see anything, and that should be the case. So that's where symbolic link comes into existence, and yeah, it's used pretty much. Let's do a basic example. I think that would be good to help you understand. So let's write some text here. I'm writing in 1.txt. Hello, this is the original file, and from here I just create a symbolic link. So 1.txt, the original file, and now new.txt, hardlink.txt. Oh, sorry. Okay, hl.txt, ln. Oh my god, sorry. ln1.txt, hl.txt. That's what I was thinking. Yeah. So hl.txt. So do hl.txt hello, this is original file. Now if I make the changes to the file, second line is being added, and if I view cat hl.txt, see, the second line has been added here. And now if I delete one.txt, okay, I was wrong here. I was wrong with the hard link. I thought the file would get deleted itself, but it doesn't get deleted. It just stays there as the original file. So yeah, this is the hard link. Like if we make the change here, it will appear here, but it will stay here. Now let's do a symbolic link. And oh, I thought I forgot about the cp command. Cp is just like copy the contents of one file into the other file. Cp hyphen r stands for recursive generally, so it will copy the whole directory from one place to another. So if I do one.txt now, I have the original file back, and I can delete here. So if I do ls.txt, sl.txt, ls, now you see sl.txt is a green link, so it tells you that it's a symbolic link. So if I do cat sl.txt, I will be shown this thing, this file. Now if I make the changes one.txt, third line was same file. Okay, what is happening here? Yeah. Okay, I got it. Now symbolic link is opening the file here, but if I delete one.txt, I expect that it won't open the file. Yeah, see, there is no file here because the original file is deleted. So that's how you go about it with the hard links and the soft links. This is a basic cheat sheet that I built. Touch, I've explained for the file, cat, concatenate, nano, command it, copy. MV is a very basic command. So if I want to move something, I don't have a GUI here. So what if I do is mv to 2.txt to home, okay, and let's move it to music and ls. We don't have 2.txt anymore, but if I do home, okay, music, I have 2.txt here. So okay, don't do that in the songs. That's about it. And rm is to delete the file. rmrf is used to delete the whole directory in itself. So if I do test directory, if I do rm test directory, it's a directory, it just doesn't belong, but I have to do recursively delete one by one all the files in the directory, and it will do. Now if I see ls test, we don't have anything like that, it's deleted. That's what rmrf is used. chmod, chown, oh, let's talk about it later. First, grep, awk, and pop. These are very important, very good commands. So think of it first. Grep is used for finding text inside, or finding text patterns, I would say, inside the files directories, or any text output that appears on the terminal. So what I do is, let's say I create a test, I create a file, uh, it makes it that first. I create a file, touch1.txt, write some content in it, 1.txt. Let's do lorem, it's generator, let's do something. And do cat 1.txt. So this is the content that is generated. Now if I want to search for something in this content, how can I do that? So let's do cat 1.txt grep lorem. Now I have written this as a pipe. A pipe is the output of one command, that is cat.txt, becomes the input of another command, that is lorem, to search for word lorem in the output of this command. So it just makes all the lorem words appear. Now there are many things, like if you want to just search for search it as regex, search it as what I would say in a specific format. So currently if I do lorem, it won't search anything. So I can make that like in lowercase, uppercase, anything like that, in a fuzzy search way I can do that. Grep is a very vast command, but yeah, it's mostly used for searching the patterns that are inside the text. I can do like this also. Sorry. One.txt. I can do it like this also. It won't find anything because there is not. You can do it like this also. Grep lorem, find the word lorem, 1.txt here. But yeah, I generally prefer it with cat grep lorem like that. And yeah, it's mostly about that. Now awk. Awk is also a very great command. Awk is used for text editing, I would say, scanning, printing out columns, and whatnot. Let me think of an example where we can print columns. Okay, let's do that. We have a lot of files here, and here the text is arranged in columns: first, second, third, fourth, fifth, sixth, seventh, eighth, like that. Now if I want to do just $1, so it's like awk, the command starts print the column, first column, and it just prints the first column of it. Now if I want to print $1, $2, 1, 2, 3, I think so. No, it's like that. $1, $3. Yeah, so I just make a space in between it. So just prints like that. And now I do again a pipe. I want to count how many rows are there. So of this whole output, so first ls-la output comes, then awk makes and prints just 2 columns of it. Now I'm teaching something else. wc is the word count command, and it counts number of words that are present in the second output. So this second output gets feed as input to the third command. 70 characters, 70 words, 70 lines, and 132 characters. And if I just want to print how many lines are there, like this. So this is all about it. And. So here in Linux, like the official directory is for like you can search it on web and you can get like all of this directories here. Grep searches for patterns in each file or extended, like all of this is present here, like you can view it here. There is an easy way to do that. So if I do man, that is manual pages that we just opened. If I show you, so Linux manual page, this site is also manual, so manual page. And if I do grep, I can search for any command here, and so this helps a lot. Now here I can do grep on the grep page to find patterns in the text source. And by example, I search for regex. So I do a regex, and I want to do 10 lines before a word regex is found, a pattern regex is found, and 10 lines after. So I do A10 hyphen B10 and do like that. So I just have a little bit more context of what's happening. So if you look at it, 1 2 3 4 5 6 7 8 9, and like this also 1 2 3 4 5 6 7 8 9 and 10th. So here 10 lines before 1 2 3 4, it prints like that. Extended regex, fixed strings, perl regex, word containing matches that form whole words. So let's try this. Regex. Woof, all of the words. So think of it like this is not a whole word. This is something just as a hyphen here. And this is a whole word. That's why it appears here as a whole word. So yeah, we can do man, any command. If I wrote about man pwd, so if I do a pwd here, print name of current working directory, logical, physical, anything. It doesn't have anything else apart from that. So yeah, like this. Now comes the last command, that is stop. So what is stop do? Top is, let's look at first the man page of top. Display Linux processes. This is the command that we're gonna use, that we use a lot in our systems engineering to learn more about what processes are running. There are many more commands that you can use. There are many directories that show. There is one directory that is /proc that shows what are the processes that are running here, but in a very visual and fast way you can see the processes that are running here. We will be exploring a lot more about these K workers and everything that is running here. So I'm recording with OBS. The command is OBS gnome shell. Here user is Mononoke, like me, priority Nick. These all are very important things. These are very, like, it doesn't look like it shows much, but it shows a lot of things about what is happening and what's the current state of the system. Now top is what is given to us by the Linux kernel by default, but as you see, it isn't very, like, if you don't have anything else, yeah, top is the way to go, but it isn't very fast, I would say, like very intuitive to see, because memory, whole of it is, this is free, this is that, swap is didn't being used. It gives very vital information, but it doesn't show about short-lived processes and something else, and it doesn't have a intuitive way to more about it. So there is one more command, that is atop. So if you look at it, it shows the per CPU distribution that top didn't have. I know in the top we can like set different things, different parameters, like to show about CPU everything, but yeah, it just shows by default here. So I generally like to use atop, but yeah, if you have a server that doesn't have anything, top is the way to go. We'll learn more about specific system engineering commands in detail in the later videos, but this is just an introduction to it. And all the processes that are running here, total memory, this. A very intuitive way about ATOP is this. Look at this. So processors, it shows 20 processors, that's why 20. And about this is the disks that I have. Disk is my 92%. No, sorry. Yeah. Okay. Interface is about the Wi-Fi and everything. So if I just turn on a video on YouTube, 4K video. Let's do that. So let me just mute the site and let me do. Okay. Oh my god, there is a lot of ads. Now if I do, let's say a 8K video, because it loads more data, you will see here my Wi-Fi is just spiking up a lot. So it's loading RX is received bytes. So mega, so if you look at it, megabits per second, it's loading and trying to load the data. Oh my god, what a beautiful video. But yeah, it's struggling a bit here. Let me do it 4K. Now you can see here, and this is all what's happening in the memory. The swap is completely full. We'll learn more about this in details in other videos, but yeah, this is about it. Let me turn that off. And yeah, oh, there is one more thing, that is two more things, that is like chown and chmod. So chown and chmod. Chown is like, so when I create a file, let's look at this ls/la l1.txt. When I created a file, it has monoke. What is this? So this is the user, this is the group, and last access time is this, and it was created I think on June 19th is last access time. This is I think the inode number. Let me do use long listing format, and here long, where is slash use a long listing format, it lists I think it's the inode number. Inode number is, so every file in Linux has a number attached to it, a unique number that is attached to it, and that is the inode number for it. I might be wrong here, but yeah, let me confirm. Oh, it's a file size. Sorry. Yeah, it's a file size in bytes. Like if you do ls/lh, it will show you like in KB, MB, but yeah, it's in bytes of that type. And here I was telling you about these. So these are the permissions. So grep is a file, it doesn't have anything, but rest all of them are directories, that's why D. Then read write executable, read write executable, read write executable. There are three things. So first read write executable is, there are three, let me open Excalibur. That would help you a bit here. So it's like read write executable, read write executable, read write executable. Now everything that's, and this is the directory or character file directory, or just a file here like this. Now what does these mean? So this is for the user, this is for the group, and this is for others. Now a user has the permissions for read, write and execute. A group in which the user is, what permissions does that have on the file? Read, write and execute. What permissions does that have on the file? Read, what others? Like others is everything that are not in the group and are not the user that created the file. So that those are others. Now chmod changes these permissions, change the modifications, like do the modifications on the file to change its read write executable, read write executables and everything. So this is very important. So if you want to have a file that can only be read by the group of the users, what would you do? Very simple way. Even the owner of the file, if he wants to read it, he can only read it, not execute it. Then you would like to set the permissions like this. And others, like if I don't want to give them any permissions, it will be like this. Like you can do read and like this, but think of it like in terms of binary, 1 1 1, like this. So it will be 0 2 4, sorry, 1 to 4, that is 7. If I do the addition of it will be 7. So if I do 4 and 1 1, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, yeah, that will be 6 6 and 3 0 0 6 6 1. So if I do a permission of 661, I will only be able to read the file and not write to it. Let's do an experiment. So cat 1.txt, we have this 1.txt, we have read write permissions. The group when a user gets created, a group by that name also gets created. I can add users to the group, I can delete users from the group, but I cannot delete the user that is named in the group. I think that sounds logical. That should, yeah. Now if I change the permission, chmod, what we had, 6 6 1.txt. Now if I do sorry, 6 will be this 4 2 and it was supposed to be 7 here, 777, right? 2 is 1 2 is 1 2 4 is 6. If I do just a second, what I'm missing here, so it's not, let me do sorry. So okay, yeah. So now I have just the read permissions here for the file. Now if I try to write to it, I have been denied the permission. So you can think of it like this. I have a file that I can just read from it, but I cannot append to it. Think of it like a log file in your server. I just want to read to it, but I cannot write to it. Someone else can write to it. I think in a group someone might have permissions, or just sudo is a root user. Root user has the permissions. So if I want to change the file to write 6441.txt, now if I do, I can now write to the file hello and yeah, and 1.txt, and I see hello here. Now I can write to it. Sorry, I just messed it up. Here we are 4, 2 and 1. So if I want to do 6, I do 4, 2 and like it will be, for having 7, this will turn out to be 7 in binary. Think of it in binary. 1 1 1 equals to 7. 1 1 0 equals to 6. 1 0 1 equals to 5. And 4 1 0 0 equals to 4. And 0 1 1 equals to 3. 0 1 0 equals to 2. 0 0 1 equals to 1. That's all the permissions. So read, write, executable, just read and write. Read and executable, just read, write and executable, just write, and executables are like you can run those files. So if I have a bash file, so yeah, I have a bash file, I want to run that file, I cannot run it because I'm not allowed to execute that file. That's what that's how you stop from running some dangerous files. But sudo has access to it. You can change the access of the users, the groups, etc. And yeah, that's all about it. Now if that's the ch mode, and we generally don't want to mess with this command. Like sudo can change everything, root user can change everything, but we don't want to mess with this command a lot. We want to, if we want to bind files, like pull up the files from some other users, create groups, put that in groups, and that's how we manage it as a system administrator, but we don't use that. After this is ch own. Ch own is, as we all know, ch is changed and own is ownership. Now change ownership of the file. Now if I do ls/l1.txt, so owner is group, first is the user, second is the group. So user is okay, that owns the file, then it's a group. Now if I want to change, first let's do ch own, change the option owner group file, and change the user and own file if only an owner is given. And now if I just do sudo ch own test, oh sorry, now if I do ls/lh, see the user got changed. Now if I do test, now the user with the group got changed. Now others can read to the file. Now who am I? I am Mononoke. So now if I become the others, now if I write to that file, I shouldn't be allowed. Let's test it out. Yeah, but we are masters. We just do 646 1.txt ls/h. We got the right permissions. 1.txt hello from okay, and sorry, and we do that 1.txt. See hello from okay. So rm, so I'm just going to read it. I think the work is done here. Yeah, that's all about it. Change the group and the users. Now in the next video there will be a very short project on the users and the groups. So I hope you understand users and the groups like their literal meanings in the real world. A group is a subset of a group contains a lot of users in it who has special permissions to something you want to give it to it. So think of it like there is a team of system administrators that are administrating the whole lot of clusters. Every cluster they install Linux, they add a group like sysadmin1. Sysadmin1 can access all the files, all the root directories, but you as a user are given access to that system, and you can only view the files that are in your home directory. You can do just this. Apart from this, you cannot like go up and do this anymore. So that's where a group is needed for limiting the access to certain things. Linux uses this all times. If I try to make the changes to some of the files, so if I do something to like init like this, see the user is the root, group is the root. Now if I won't try to delete it, like I think I can delete it because I'm running 618 kernel. Let's try, but I know it won't get deleted. It's a very important file. I can fuck up my system. Okay, sorry. Yeah, you cannot. uh, oh, just a second. Yeah, if I do, I can delete these because my kernel, I can see my kernel with this, so I'm running 618 kernel, so I can probably delete 617. Let's try rm. Let's first look at the permissions. So read write executable, only root can delete it and everything in root can do, but and it's not a directory. I can see from here it's not a directory. So yeah, and just try to delete it. This 6.17. Oh, I can read and execute it. Let's do it. Permission denied. Yeah, I won't be able to do it. I'm permission denied. See, you get a little stressed if something goes wrong, but yeah, it won't happen. I trust you smoother than myself. Uh, that's all about it. But yeah, in the next video, I think I'll be discussing more about the users and the groups, how we can create users, how we can create a group, how we can add users to a certain group, how we can remove users from a certain group, and a short project like we can like clearly see if I try to use this file that is I'm not a group of, will I be able to view it or not, and some stuff like that, because this video is gonna be very long, has been very long, so I just wanted to point out that thing. But yeah, thank you very much. I hope you like it, and just comment down below if you have anything that you want more to be discussed or anything else. But yeah, again, very much thank you.